and dealt with O&M of T&D systems, trained Power Grid Corporation engineers, PGCL engineers. Then he went on-site training at Infosys, also to Paradeep, Orissa for the IFCO engineers, and EMCO Pune, Tata Steel Jamshedpur. And he also trained engineers and supervisors of electricity department of Afghanistan in Kabul for 2 weeks. He trained foreign nationals from Bhutan, Nepal, UAE, Afghanistan, and from 2009 he is Deputy Director NPTI. He went to Northeastern region, Guwahati, Assam, and trained Power Grid Corporation engineers at Northeastern region. From 2012, he is back to Neyveli as Deputy Director, conducting many international and national seminars. He participated in many conferences and workshops. He is of the Indian Institute of Engineers and published papers of relevance. He received Corporate Excellence Award for Best Assistant Director in NPTI, Best Trainee Award from Corporate Office of NPTI, develop computer-based training for the ESP, electrostatic precipitators. With this small introduction, I hand over to Mr. Muthukumar to take over the platform. Thank you, sir.
Thank you, sir. Thank you, sir. Thank you. We welcome all the participants. First of all, I thank Dr. G. Sambandam, Advisor Electrical Sciences, KCG College of Technology, for arranging this wonderful AICTE sponsor online short-term training program on cyber security and the lessons of smart grid. And also convey my thanks and blessings to Ms. Gayatri and Ms. Anna Dhanlashmi, Assistant Professor, for their hard work and regular contact with me and other faculty members for making this a success. Today's topic is on electrical grid operation and introduction to smart grid. The content is like this. We'll have basic discussion on power system, power plants, and then we'll see electrical grid and what are the requirements of grid, and voltage and frequency control. What is the role of Electricity Act 2003 in controlling this voltage and frequency in the grid system? Then we'll also discuss on Indian Electric Grid Code. This is controlling the grid discipline, and we'll have discussion on load dispatch center, scheduling, entitlement. Also, to have grid discipline, there are some enforced deviation settlement in the availability based tariff. We'll touch upon that also. This will take 55 minutes. Then another 5 minutes we'll discuss on problems in conventional grid. What are the problems we are facing actually? And this will take for 5 minutes, so 1 hour. Then need for smart grid, why we are going for smart grid, what are smart grid mission and working groups of smart grid, and what are the government initiatives, Ministry of Power, Government of India initiatives for the smart grid. And based on these initiatives or guidelines only, all the sectors, private sector, government sectors are working hard to make this smart grid success. So this is our content. Total 1 hour, 20 minutes or 25 minutes we'll have discussion. Into the power system, electrical power in India is one of the vital input to industry and economic growth, as Dr. Sambandam and Reliance are discussing. It is GDP of the nation, gross domestic production, depends on the power production, because without what there are no industries, no chemical industry, no steel industry, no cement industry, etc. Normally, allotment of budget, 20% of the budget allotted to the electrical power. This shows that what is the importance of the electrical power, and this is a basic for growth of our nation, growth of our industries. So economical growth based on our electrical generation growth. So this plays a very important role in economical growth of the country. This power system basically divided into 3 parts, as you know already: generation, transmission, and distribution. Power generated from one place is transmitted to other locations through transmission lines. and distributed to the consumers. On consumer, we have many types of variety of consumers, starting from domestic consumer, industrial consumer, industrial, HT consumer, LT consumer, railway consumers, agriculture consumers, and many variety of consumers we have. So to all this, our grid should supply the supply or electrical power with quality power. That means the voltage and frequency should be in prescribed range without any harmonics. That is what we say quality power. Violence are also discussed about this. Quality power means only the voltage should be prescribed level. 230 volt means 230 volts should be supplied, but there are some deviations allowed as per guidelines. And the frequency should be 50 Hz, and the CRC, Central State Regulatory Commission, recommends some deviation of frequency, that is only allowed, and harmonics also. And these are the basics of just 5 minutes we'll see. Conventional power plants, and we have non-conventional power plants. In conventional power plants, these are power plants utilizing the fossil fuel, solid fuel, liquid fuel, and gaseous fuel. Thermal power plant through steam generation, this generating the power. And in India, more than 60%, almost 65% of the power generated from the thermal power plants only. This plays a major role in power generation in our country. Then we have nuclear power. Nuclear power last power generation Kodangulam. Total we have 6080 megawatt. We'll see detail later. And nuclear power plants. And of course gas turbine also. Cost of the power generation is a little more, but still we use this for the peak hour, meeting the peak hour demands. And diesel power plant also, the cost is more, so we use for peak hour, meeting the peak hour demands. And we have non-conventional power plants, like wind power plant and solar power plants, and biomass power plants using bacchus, etc. And of course, we have tidal power plant also. Then coming to grid. What is electrical grid? What is the requirement of the grid? Here only our session starts actually. The electrical grid is a high voltage electrical power transmission network connecting power station and major substations. So electrical grid nothing but connecting all the generating stations, all the transmission substations. So whatever the power generated from anywhere can be transferred to anywhere. That is our aim. You can see here the power generating station, or here also power generating station, it is taken through transmission system to the distribution sector or load centers. And this ensures that electricity generated anywhere can be used to safely satisfy demand elsewhere. Whatever, now see, we are generating power in Neyveli. It is not only used in Neyveli, it is to be taken to the load center. So load center, Chennai, Trichy, Madurai, these are the load center in Tamil Nadu. And as it is a central power, it is taken to other states also within the region. We are located in southern region, which consists of Tamil Nadu, Kerala, Karnataka, Andhra, Telangana, and Pandi Puducherry Union Territory. This power generated from the NLC taken to all the various places in this region through transmission system. That is called, we say, grid. So power generation station, they step up generator, step up transformer. And you know the reason why we go for step up the transformer, because high voltage will have very less losses. Then transmitted through transmission lines 110 kV, 220 kV, 400 kV, 765 kV. This is a Indian voltage grid system, and we step down the power using a step down transformer at receiving substation. And it is we have sub transmission customer, and we have primary customer and secondary customer. These are the house load and commercial load operation. And primary 11 kV, 22 kV, it is called LT industry, HT industries. And we have some of the consumers, transmission consumer, like steel plant or cement plant, they take power from the 110 kV or 220 kV. The main reason is when they take power from 220 kV, 110 kV, the disturbance will be less. If at all there is any problem in the consumer end, and only they are going to shut down this place where the primary side place or primary switchgear area, the transmission line will not be disturbed. So that is the reason the people, some of the heavy power consumption companies, they take supply from the transmission system 110 kV, 220 kV. Like railway also, they take power from the 110 kV, 220 kV. And 11 kV, 22 kV, these are the primary consumers, industries, HT industries, they take power from the grid. And what are the grid requirements? Our grid should be able to supply reliable power. What is reliable power? Reliable power is 24 into 7. 24 into 7, all the time power should be available in the grid or to the consumer. That we say reliable power, and should be a quality power. What is quality power? Quality means it is a frequency in the 50 Hz range, 50 Hz range, and voltage in the prescribed range, because we have voltage classification from starting from low voltage. Low voltage, we say this 230 volt is called a low voltage, and 415 or 440 volt called a medium voltage, and high voltage is 11 kV, 22 kV, 33 kV. These are called high voltage. And sub transmission voltage we have 66 kV, 33 kV, and 110 kV we say extra high voltage system. 110 kV, 220 kV, 400 kV we say extra high voltage system, and we have 765 kV we say ultra high voltage system. These are the voltage system in India. And of course we have 1200 kV pilot line also in India, which is coming up. But now, earlier the 400 kV was the backbone of India electrical grid. Now it is 765 kV is becoming backbone of electrical grid in India. And economical power. See, whatever the power generated, it should be economical. For example, if we take any domestic consumer, he pays, let us say, 1 rupee 50 paise, whether power generated from thermal station, nuclear station, or gas turbine, or diesel power plant. Generation of power from thermal station may cost 2 rupees, diesel power plant may cost 7 rupees, and gas turbine may cost 9 rupees generation cost. But the consumer pays same money. So the supplier or utility should not incur any losses. So the supplier or utility should be able to, or power generator people should be able to generate the power which is more economical. And we have we say grid merit order system that we'll discuss later. As per IEGC, merit order system generation should be there. So our power should be reliable, available for 24 hours into 7, and should be quality, that is a frequency, voltage, and with less harmonics, and it should be economical. This is our system. You can see there's a power stations connected to transmission lines. This is what we say our grid. That is why we discuss power quality, frequency, voltage, and level of reliability. All the place we have, for example, this if we take a 230 volt, 440 volt, this all there are some deviation allowed. This deviation is normally plus or minus 6% deviation. That is what minimum allowed. It should be the voltage supplied should be within this limit only, within the deviation 6% limit. When we go for higher voltage, or lower side we allow minus 10%, higher side we allow 10 to 12%. So why? Because when we allow more voltage variation at the higher voltage side, using a transformer we can increase the voltage, tap changer, etc. Or using some other fact devices, we can increase the voltage when it is reaching the consumer end. That is a deviation at the higher voltage is allowed more, and deviation at the lower side, that is 230 volt and commercial 440 volt 3-phase system, the deviation allowed is very less. It is only plus or minus 6%. When you go for higher voltage, it is allowed up to 9% or 10% also. The reason is voltage can be boosted up, but as per frequency concerned, it cannot be boosted up. Frequency, what is the frequency generating station? Same frequency up to the consumer end. So whatever frequency at Kanyakumari, we can see same frequency at Kashmir. But voltage is not like that. Voltage will be differ place to place and depends on the line length and resistance of the line. We say drop in the line. So grid means we have to maintain the voltage and frequency, and voltage and frequency should be controlled. That is the main aim of the grid system. Okay, why we discuss all this? We are going to discuss only the conventional system, grid system, and what is the problem in this system, and we are going to see next smart grid system. What is need of smart grid? So first of all, we should know what is the voltage and frequency control. Why it should be controlled? If at all the voltage is more or less, what is the problem? If the frequency is more or less in the grid system, what is the problem? Now the problem is why we should have constant frequency. We are operating the system 50 Hz system. If it is not operated 50 Hz, what is the problem? What going to be the problem at the consumer side, at the same time at the generator side also? So frequency fluctuations are harmful to electrical appliances. You can see any nameplate detail of any electrical equipment rated for 50 Hz system. Our voltage also mentioned 230 volt, 440 volt, etc. So all the equipment rated for 50 hertz, the rated frequency is not supplied, then we'll have problem. What is the problem mainly? Normally we take the example for motors. Why we take motor is, out of total power generation, more than 79% power consumed by motors in the system, in the electrical system. You take our household appliances, we have grinder, we have mixer, mixie, we have fan, all run by the motors. Go to industries, all the electrical drives or mechanical drives are run by electrical motors. So electrical motor plays a vital role in the electrical industry. It occupies more than 79% of the electrical utilization. Remaining, we have lighting system, small lighting system and some resistive loads. We have like iron box, heater, etc. And we have some of the capacitive load also for a voltage improvement, power factor improvement. We have some capacitive devices in some of the industries. But mainly we have inductive load in the grid system. So speed of the three-phase AC motor proportional to frequency. When frequency goes up, voltage speed of the motor goes up. So speed of the motor is a very precious. Some of the industries we have to maintain constant speed of the motor. So for example, you take a textile industry, a spinning mill. If the constant speed is not maintained, then we have problem in the quality of the spinnings. Same in the cement industries also. When the voltage is frequency is low, the speed of the motor is going to be low. So we have to maintain the frequency in the system constant within the range. If it is not so, then we have problem in the appliances side. And of course, you can see our lighting system, domestic lighting system also. The frequency is low. You can see the difference in the lighting system, difference in the fan speed also. At the same time, coming to generator side, the blades of steam and water turbines are designed to operate at a particular speed. Normally, see, we told this more than 65% of load made by thermal power plant. And thermal power plant, you know, we have boiler, turbine, and generator. Turbine, coming to turbine, turbine has to run at synchronous speed. That is 3000 RPM normally for the thermal stations. If the frequency is more, that means what? There are conditions why the frequency is more that we'll see. When the frequency is more, our turbine blades, particularly LP turbine blades, low pressure turbine blades will have problem due to centrifugal force. It will get damaged. So mainly not only appliances side we have problem in the generator side also. At the same time, frequency is low, then turbine will get problem. That is called, it will go to critical frequency, or it is called natural frequency. Less than some frequency, the turbine will have more vibrations. So as per the both the conditions, consumer side and utility side or generator side, both the conditions we have to maintain the frequency. With the frequency higher, turbine will have problem. Frequency lower, again will have problem in the turbine. But it's not a big problem with the generator side, but it is a problem with the mechanical equipment turbine. Due to centrifugal force, blades will get damaged. Lesser frequency due to vibration, the turbine will get damaged. So plus or minus 3% it is operating safety region, safe operating region. As per old IE rules, Indian industry rules, which says that any equipment can be operated plus or minus 3%. That is 48.5 to 51.5 hertz. That is a safe operating region. This, but not a grid frequency, or it is to be, what is it to be maintained is different. What is to be maintained now, frequency operating range is 49.95 to 50.05 as per CERC regulation 2009. So they have narrowed down. Earlier it was 49.5, 49.49, and now they have narrowed down to 49.95 to 50.05. That is a range of frequency operation. So plus or minus 3%, what we say, it can be operated. The equipment will not get damaged. At the same time, we have to maintain what we have. We should maintain the grid at 49.5 and above, within less than 50.05. When we operate the region with the higher frequency, simply we are wasting our energy. There is no higher frequency required in the system, but we are injecting more power, or we are injecting more fuel to have higher frequency. It is a waste of energy. So we have to maintain within this 49.95 and 50.05. It is like plus or minus 3% is like a student getting the pass mark, and 49.95 and 50.05 is a person getting the first class distinction. So it can be operated, but should be operated. This is a grid discipline. This should be operated within this narrow range only as per regulations. Then what is the voltage problem? If it is higher voltage in the system, again we'll have same problem. Electrical motor will tend to run on overspeed when they are fed with higher voltage, resulting vibration and mechanical damage. So higher voltage also we have problem. Mechanical damage will happen, vibration will happen, and at the same time there is insulation failure in the electrical system, transformer, motor, etc. Under voltage, when we go for under voltage for same power, current run by the equipment is more, and it is leading to more losses in the system. Simply we have to incur more losses in the transmission distribution system. So it is not desirable. Over voltage, under voltage, it is also not desirable. Over frequency, under frequency, this is also not desirable in the system. So all we are aiming for keeping this voltage and frequency constant. Now we discussed what is the problem with the higher voltage, lower voltage, higher frequency, lower frequency. Now how to control this voltage and frequency? There are some control parameters, control mechanisms to control this voltage and frequency. As you know already, at generator we generate active power and reactive power. Active power and reactive power. Both power generated from the generator, because active power we say is the useful power, or reactive power we say magnetizing power. Our load, most of the load is, or more than 80% load is inductive load. Inductive load means motors, fan, etc. are inductive loads. For inductive load, you know the operation of inductive load without reactive power cannot be started. So reactive power is required for continuous operation. Active power also required. So active power and reactive power. Active power controls the frequency. Active power is lesser the supply, then frequency will be lesser. Active power is more, than frequency will be more. So it shows the balance of load and generation. Load and generation. If the load is lesser, generation is more, then it is a higher, leading to higher frequency. Generation is less, motor load is, or grid load is more, is leading to lesser frequency. So load frequency control done with active power, that is a prime mover supply, prime mover system. In a thermal power plant, the prime mover is the turbine. By opening the governing system or closing the regulating the governing system, we can control the frequency. What is frequency? Frequency nothing but speed of the turbine. Nothing but speed of the turbine. So if we are able to control the speed of the turbine, then frequency can be maintained. So according to the load, we have to regulate the governing system valve to open or close to keep the speed constant, that is 3000 RPM. Then we can maintain the frequency 50 Hz in the system. Normally we say why 3000 RPM, you know, it is a thermal power plant generators are 2-pole machine. Hydro power plant machines are 4-pole or 6-pole machines, so speed is lesser in the hydro generator, speed is more in the thermal generator. You cannot have more than 3000 RPM speed in any generator, because minimum number of poles required are 2. So we'll have maximum speed of any prime mover is 3000 RPM. And reactive power. Reactive power controls the voltage. The reactive power supplied to the generator or supplied from the generator is more, then voltage is more. If it is less, then voltage will be lesser. How it is controlled? Voltage control from the automatic voltage regulator, that is excitation system of the generator, starting from the generator side. Any generator will have excitation system. The purpose of excitation system is to generate the voltage, to induce the EMF in the stator, and also to keep the generator terminal voltage constant, and also to keep the reactive power demand in the grid within the limits. So automatic voltage regulator or excitation system plays a major role in controlling the voltage and supplying the reactive power in the grid. And capacitor reactors. Capacitors, of course, this is called reactive power generator. Reactors, it is called absorption of reactive power. When the voltage is more, we switch on the reactors to absorb the reactive power so that voltage can be maintained. Normally, these reactors are provided at the receiving end of the 400 kV, 750 kV lines. And the switching surge should not happen. So we have reactors. And of course, we have tap changing transformer also. Transformer tap change will increase or decrease the voltage in the system, which is also one of the reactive power absorber as well as increase, or it is giving the reactive power to the grid. So these are control parameters: active power, reactive power. To active power controls frequency, reactive power controls the voltage. So we have to manage or balance this load and generation. Load and generation should be balanced. Then only we'll have constant frequency, constant prescribed voltage in the grid system. Net surplus power, net power surplus frequency increases, net power shortage frequency decreases. So the frequency depends on the active power. And frequency control, as we have discussed already, this is can be controlled by generator side using the prime mover, that is the excitation system, and the demand side using the low frequency relays. Normally we use low frequency relays in the demand side. That means if any the frequency goes down, that means what? The load is more, generation is less. So if we curtail some of the load in the system, the frequency can be maintained. So using the low frequency relays, when the low frequency relays, let us say grid system, we have 49.5 hertz or 49.4 hertz. That means what? Our generation is less and demand is more. So we curtail some of the load, some of the transmission lines, 220 kV, 110 kV lines, according to the grid system or frequency range, it will be cut off or opened. Circuit breaker will be opened so that our grid frequency can be maintained. This is a system normally we follow for the frequency control. Generation side we have excitation system, that is called primary control, and transmission line side we have demand side control. And of course it is a frequency control system, and we have under frequency load setting. Sometimes you may see load shedding also happens in our system, in our Tamil Nadu, any state. This is because to maintain the frequency in the system. And of course, voltage control, already we have discussed with the use of excitation system and automatic voltage regulator. And using the tap changes, we can control the voltage in the system. So these are the two factors to be controlled, voltage and frequency. There are two factors to be controlled in the grid system to maintain the grid discipline, And of course, we discussed about fact devices also. Fact devices, series compensators, static or compensators, series capacitors, and tap changing transformers or boosters also used for the voltage control. If this voltage is more, then we have reactors. Voltage is less, we have capacitors. We have two types of capacitors normally: the shunt capacitor and series capacitor. Series capacitors are used in the transmission line to have chronological increase in the voltage. Okay, now coming to what are the reasons our grid should collapse or system collapse due to grid discipline? What are the reasons for the system failure? What is system failure? In the electrical grid system, it failures due to sudden variation of system frequency. If the frequency is very low or very high, then this happens. Then violation in the form of normal frequency, abnormal voltage profile. The voltage is very low or very high, abnormal profile, voltage profile. This also leading to our grid failure. Overloading of transmission network. Overloading leads to low frequency, low voltage problem. So overloading of transmission network also leading to system collapse. And violation of generating and load trial scheduled by the constituents. Morning violence are also must have discussed regarding this violation of rules. There are states they fixed with some entitlement like now TNEB or we say Tangentco can draw say 250 megawatt from NLC, they should draw only 250 megawatt. They draw more power, then it is leading to problem in the total grid. So violation of generating and load trial also leading to grid collapse. So grid collapse, one of the example we'll see already might have discussed, but still we'll see. We throw light on this northern grid failure which happened 31st July 2012, and this is a condition. Northern grid, it was with the generation of some 32,000 megawatt. Demand was at that particular time. The time is 2 hours, morning 2 o'clock, 30th July 2012. The demand was 38,000 megawatt. So import it was happening 5,000, more than 6,000, around 6,000 megawatt. It was going from, you can see the figure WR to NR. That is western region to northern region. And of course, we have different regions. Let me complete this one first. Prior to 1991, we have 5 electrical regions: southern region, western region, northern region, eastern region, northeastern region. Southern region consists of, as already discussed, it consists of some 4-5 states like Tamil Nadu, Karnataka, Kerala, Andhra. Earlier Andhra, now it is Telangana also to be included, including Union Territory Puducherry. And western region it is Maharashtra, Gujarat, etc. Then northern region it includes Haryana, Himachal Pradesh, Kashmir, UP. Eastern region includes Orissa, Bihar, Sikkim. The northeast includes, there are 6 states, northeast states: Assam, Meghalaya, Manipur, Tripura. etc. These are 5 electrical regions. We'll come back later. So the power was flowing from western region to northern region. Why? Because WR, the western region consists of more power plants like Tata Power, Adani Power, and other how many power plants in Maharashtra and Gujarat. Because it is a coastal area power plants are more in the western region. And power, you can see here, power was going from eastern region to northern region also. Eastern region also consists of many minings, coal mining, Bihar, Jharkhand, West Bengal. These are the states, plenty of mining, coal mining. So mining was there, so power generation is more. So eastern region also giving supply to the northern region. And of course, we normally we get from northern region also supply because it consists of many hydro generating stations. And of course, during that time, 30th July 2012, the southern region was separate. Again, I'll go back this one. Come to this slide. So 1991, what happens? Now eastern region, northeastern region synchronized. 2003, western region, northeastern region, northeastern region synchronized. 2006, new grid, that is formed new grid, that is NEW, N for north, E for east, and the W for western, and the first NE again come back in the northeastern region. So it is called new grid and southern grid. 2006 onwards, up to 2013, the grid was like this only operating. All 4 grids are together operating, called as new grid, and another one is called southern grid, which is our grid in Tamil Nadu and other states. This is a condition. During this condition only this happens. This failure happens. So southern region was separate, totally separate, but it is drawing power from the WR western region and north eastern region through HVDC lines. Since it is a different frequency region, cannot be connected with the AC links. That is a problem in the AC link. Without the frequency synchronizing, we cannot take the power or send the power to other region. So from western region through HVDC it was connected. From eastern region also, southern region was connected with DC lines. That time, the 2 o'clock, the frequency it is 50.01 and it is 49 Hz, 49 point. Southern region was little lower. Okay, this is a condition. Now you can see why we go for integration of the grid. After that, we will go for the failure. Why we should go for integration of the grid? This is resource share. From eastern region, northeastern region, power can be transferred to southern region. It leads to grid stability. Single high capacity grid stable to small distance. For example, if we take a grid consists of 10,000 megawatt, 10,000 divided by 50, it is called frequency number, that is 200. That means in a 10,000 megawatt grid system, if 200 megawatt failure occurs or generation failure occurs, the frequency will go down to 49 Hz, and that is one frequency lesser. But if a grid is total combined 3 lakh megawatt grid system, after 6,000 megawatt failure only the grid frequency will go down to 49 Hz. That is a advantage of this integration of grid. Not only resource sharing, resource can be shared from other region to the less resource region. Then grid stability can be obtained by integrating the grid system. So these are the main why we go for integration of the grid: resource sharing, grid stability, and we have frequency number. Coming back in this system, what is happening? You can see the figure now. What happened on 30th? So heavy load happening in the northern region, trial of heavy load. That is what we already said. The discipline should be maintained by the grid managers or utilities. What are the allotment, that power only they should draw. If they draw more power from the grid, then it leads to grid failure. Then 1210, what happens? There is a first 220 kV line from NR2, that is northern region WR breaks. The 3000 megawatt supply to northern region dropped. Already it was 5600 megawatt it was drawing. Now 300 megawatt out. Now after 5 minutes, what happened? Second 220 kV line from northern region to the western region breaks. So another 270 megawatt from WR to NR, western region to northern region supply dropped. The huge power transfer occurs. Okay, transfer occurs 400 kV critical line. That means now overdrawal occurred. Now northern region is drawing over power through this 400 kV line. Now what happened? Third 220 kV line also from northern region to western region breaks, and further 280 megawatt. Almost you can see 1300 megawatt, almost 1000 megawatt, 300, 570, 770, 850 megawatt, almost 1000 megawatt, nearly 1000 megawatt load is not available to the northern region, which is almost 20% or 20 to 25% of power shortage. Then critical Gwalior-Agra line 400 kV line also trips. This 400 kV line, it was having more loaded or overloaded line. This load also tripped at 233 minutes. So around 220 kV line trips, another 220 kV line also trips due to this low voltage again problem. So almost all AC links between the northern region W are lost. So huge western region, eastern region, northeastern region links prevail, but highly overloaded. Links are there. Some of the links are there, but it's highly loaded. So what happens? The 222 to 400 kV Rourkela Jamshedpur line also, eastern region to northern region, high capacity lines trip due to overload. So again, further 400 kV eastern region to northern region line also shut down. So what happened at 2 hours 34 minutes? Total NR grid goes extremely low frequency and it leading to northern region blackout. So unless otherwise maintain the grid system, voltage and frequency in the grid system, it is very difficult to maintain the grid discipline or grid failure. So grid failure can be avoided by maintaining the voltage and frequency in good condition. That means we should be able to know what is a demand, what is a load, what is a generation. So we have to match this generation and the load in the system. That is a important work of the power players in this system. You see here, the frequency, it goes down at 2013. So frequency, it was oscillating at nearly 50 Hz system. At time of failure, to 34 minutes, you can see here, the frequency goes down, very drastically goes down. This is a reason for the total blackout. You can see here, this is a northern region grid system, northern region, and here you can see this is at the western region side. So western region it was maintained, and the northern region it was, since it was drawing more power, the last occurred frequency gone down. And you can see here western region frequency it was maintained, and since some of the loads are disconnected from the western region, the western region frequency goes up, and northern region frequency comes down. Northern region comes down. So why this happens? Western region, how it escaped? Western region having its own generation. Northern region was drawing power from the western region and the eastern region. So the link from the eastern region, western region to northern region isolated or cut. So western region escaped because it's having own resources, own generation, but northern region not having own resources, own generation. It was drawing from the western region. So this is a problem. This is a problem in the northern region, the grid failure occurred. So what I want to say is, unless otherwise you maintain the voltage and frequency profile in the system, it will lead to grid failure. So we have to operate the grid without violating the rules. Without violating the rules. So after this, what happened? On 31st December 2013, this southern grid also connected with the new grid. Southern grid also connected with the new grid, and it became, after that we became one India, one grid system. So even our total grid system can tolerate the huge fault also, or huge disturbance also can be tolerated by connecting this new grid to southern grid. Then 31st it became one grid. And not only that, now we have surplus power we are exporting to the other foreign countries also. The SAARC countries we are exporting SAARC countries, and of course we have some plans to send power to Sri Lanka also. You can see this is one of the power sent to Bangladesh, and of course we are, I told you, we are exporting power to other SAARC and nearby SAARC countries also. This is the power. Of course, it is taken on 29 February 2020. What is the power sent to Bangladesh? Okay. Till now we are discussing about what is the importance of the voltage in the grid system, what is the importance of frequency in the grid system, and if it is not maintained, what will happen to the grid system. Now we will go to power scenario in India. During independence, the power position was, total capacity is only 1342 megawatt. Out of this thermal, it is 862 megawatt, hydro 508 megawatt, and diesel 872 megawatt. You can come to as on 30th June latest data. Thermal we have 2,30,905 megawatt, hydro 45,000 megawatt, nuclear 6,080 megawatt, and renewable energy sources we have 87,000 megawatt. Total grand total right now in India installed capacity. It is installed capacity. It is not all the plants are running. It is only installed capacity 3,71,054 megawatt. Then central government. State owns 1 lakh megawatt, 1 lakh plus megawatt. Central owns 93,000 megawatt, and private company owns 1,73,000 megawatt. Now we'll go for how this voltage and frequency controlled in the grid system, or how the grid is operated. For operating the grid, I will go in another manner. What are the companies, what are the government organizations, or what are the private organizations involved in the operation of the grid system? And I will tell what are role of these organizations in operating the grid system without deviating the voltage and frequency. The first foremost is the Ministry of Power under Government of India. This is a topmost authority for operating all generating, transmission, distribution system. Then under which we have one organization called CA, Central Electricity Authority, which is a technical wing of Ministry of Power, gives approval for any generating plant, transmission system, or distribution system. Then next is we have CGS. CGS means Central Generating Stations. Central Generating Stations like NTPC, NHPC, NLC, NIPCO, NPCL, etc. Then CTU means Central Transmission Utility, Power Grid Corporation of India Limited. This is a company taking power from the generating station and sending to other receiving stations. It owns its own 400 kV, 760 kV, and 1200 kV transmission lines. Then we have SEBs. SEB means State Electricity Board. Earlier we had board like TNEB, AP, Andhra Pradesh Electricity Board, etc. Now it is transformed to or unbundled to companies. Now we have generation companies like OPGC, Orissa Power Generation Corporation, Orissa Power Transmission Corporation Limited. Then like this distribution companies also. We in Tamil Nadu we have divided to two companies, TANGEDCO and Transco. TANGEDCO it includes generation company and distribution company, and Transco it maintains only transmission system. Then we have one more company in India called POSACO. POSACO means it is the only company. This is a company making the total system operation. Total grid system is operated or controlled by POSACO. What the role of POSACO we will see later. Then we have another corporation like REC, Rural Electrification Corporation, which is taking care of rural electrification. Then another company called Power Finance Corporation, which is financing from the World Bank or from any national bank or World Bank. It is giving finance to the other utilities, generating company, transmission company, or distribution company. Then at the same time, this is organization consists of under Ministry of Power. It is a CPRA, Central Power Research Institute, which is having testing facility for all high capacity equipments. Then of course NPT also started in 1965. It has crossed 50 years and celebrated Golden Jubilee, where I am working. NPT it is giving training to the. It is the main role is train the practicing engineers earlier. All the operating engineers, thermal power plant operating engineers are trained at NPTA. Of course, now it is operating with, or it is giving some 2-3 trainings, graduate trainings and diploma engineering training, and making placement also. It is NPT. It is creating job opportunities to fresh electrical, mechanical, instrumentation graduates and diploma engineers. And of course, we have one more organization under Ministry of Power, Bureau of Energy Efficiency. You may be knowing this is a TV, refrigerator, air conditioner, whatever we purchase. There is a sticker, Bureau of Energy Efficiency, 4-star, 3-star, 5-star. It is all given by Bureau of Energy Efficiency. So these are the major companies under Ministry of Power making the system operation very good. Now grid system, and we discussed it is a AC transmission line consists of one DC transmission line also. So grid means what? It is a connecting any power generating station with the transmission line. This is a grid. So connection of power station through AC transmission system. AC transmission lines are 1200 kV lines, 750 kV line, 400 kV line, 220 kV line, and 110 kV line. And of course, this is a system connected with the HVDC line also, 500 kV and 800 kV DC voltage. This is the system 400 kV transmission line, a single and double circuit. This you might have seen. So this is the transmission line transfer power from one place to other place, from one generating station to other load center, or connecting to generating stations, and thereby it is receiving power from both the generating stations. And of course, we have single circuit transmission line and double circuit transmission line to cater or to transfer power, more power with the use of single transmission line. Of course, we have 765 kV transmission line. Recently, it is I told it is backbone of Indian electrical grid. 765 kV transmission line and 1200 kV transmission line also existing in our country. Okay, AC transmission line, we have some of the problem in the AC transmission line like more losses. It consists of I squared X loss, I squared Z loss, we say resistance and induction loss also. So R I squared R, we say it is a power loss. What are the power generated? When it is reaching the load center, it incur losses. Technical loss, commercial loss, we say. Technical loss, I squared R loss. The R is rho L by A. The resistivity depends on the resistivity of the conductor, loss increasing. Depends on the length of the conductor also, loss is increasing. Then AC system, we have some other problem also, corona losses and radio interference. Then AC system, heavy tower, conductor and insulated sinks and more land requirements. So we cannot replace AC system, but to supplement the power transfer in the grid system, we go for HVDC transmission system also. HVDC system, transmission system, the loss is lesser than the HVAC system. HVAC system. You can see there are this. You take the first 2 towers of 400 kV. There are 4 circuits. 2000 double circuit tower, 2 towers. The power transfer, let us say it is the 2000 megawatt, but this 2000 megawatt can be transferred with a single tower HVDC system. That is advantage of the HVDC system. So it is cheaper than HVAC system due to less transmission lines and less rate of way for the same amount of power transmission. You can see now there are 2 towers used for transfer of 2000 megawatt. Only 1 tower we can transfer the power of 2000 to 2500. Or nowadays it is possible up to 6000 megawatt also. So you can see, you can assume the number of conductors are reduced, number of insulator sinks are reduced, and land cost also reduced. You can see here the terminal cost of AC. That is substation cost of AC. This is substation cost of DC, because DC means it is a AC power to be converted inverter, inverter stations and receiving and sending ends. Then is a line cost of AC, then line cost of DC. At some particular, more than some particular distance, line cost of DC and total cost of the system, transmission system reduces. That distance is called break even. Break even distance. This break even distance is around 600 km. So more than the power, more than 600 km, power transfer can be done with HVDC system, which is decreasing the cost of the total cost, project cost and losses also. So you can see here this many number of AC transmission towers lines required can be replaced with only one HVDC transmission system. So you can see the land requirement also very, very less, and agriculture land need not be wasted, and agriculture can be done with available land. So this is a very big advantage of HVDC transmission system. Advantage, control power flow and asynchronous tie is possible. Now we see, now we have made single system, single grid, but earlier before 91, our electrical region was high grid region, different frequency, operating with different frequency regions. So when it is different frequency region, we cannot power transfer with the use of AC lines. So we need DC line to transfer power from one place to another place, different frequency regions. So this is also called asynchronous operation or asynchronous tie. So asynchronous power transfer is possible with the HVDC system. Then in the grid system, we have this HVDC system, back-to-back system. That means it is used up to 600 megawatt in the sending it itself. That is a power generating side. We have the converter and inverter, both converter inverter. It is available, and the power transfer is through AC transmission lines. You can see here, these are some of the AC transmission lines. The total power capacity is only 500 megawatt and less, or 500 megawatt only. This is called back-to-back system. Let us say Vindhyachal, it is connected northern region, western region, but at the northern region it is having converter inverter station. That means the power is AC power converted to DC and DC power converted to AC with Western region frequency. So it is called back-to-back system in India, HVDC system. Then another we have is long transmission system, or we say bipolar system. Now in India we have maximum capacity of 6,000 megawatt. So 6,000 megawatt power is transferred through single transmission tower. That is advantage of HVDC transmission system in the grid system. So long distance system at sending end or generating end, power is converted to DC, and DC power transmitted for longer distance, and receiving end, the DC power is converted to AC power. Okay. This is a mode of operation. Maybe knowing this bipolar system, both plus minus, both are operating. And advantage of this system is there is any one line fails or one transformer fails, one converter inverter bank fails, with the use of available one side bank, 50% power can be transferred, which is not available in the AC system. AC system, if one phase out, then we have to shut down the total transmission line. But in a DC system, if one line fails or transformer fails or converter fails, we can transfer the power, 50% power to ground return or through metallic return also. If there is only failure in the converter inverter station or transformer system, then 50% power can be transferred through metallic. This system normally we don't use ground return, but we go for this 50% return in the DC system. So this is advantage of HVDC system, which is very useful for the grid operation. We can maintain the grid system without any much power loss in the grid system. Okay, these are the few HVDC bipolar links. This is a link available in this southern region, which is from Talsar to Kolar. Talsar to Kolar, it is 2,500 megawatt. The line length is, you can see last line is 1,367 kilometer, long distance lines. But if it is AC, the huge loss may occur. Since it is DC system, losses are very less. It is connecting eastern region to southern region. Talsar to Kolar, 2,500 megawatt. It started with 2,000 megawatt and enhanced to 2,500 megawatt with the use of 500 kV system. Now we have system with 800 kV ultra high voltage system. We say ultra high voltage system. It is connecting Raigarh to Pugalur. That is from Raigarh to Pugalur. That is a Tamil Nadu. It is connecting. It is a 800 kV line with 6,000 megawatt. See here, it is one of the line from northern region. This is the first line done by PGCL. First 800 kV transmission system in India, connecting northeastern region to Agra. That is a northern region. We are discussing about this northeastern region having many hydro power plants. So it is capacity 6,000 megawatt, but this power transfer it is only 2,500 megawatt from northeastern to Agra. The line length you can see 1,775 kilometer without any tapping, directly coming from northeast to that is Vishwanath Sarali to Agra. This is a line, DC transmission line. And one more transmission line is Raigarh, connecting Raigarh and Pugalur, ultra high voltage DC system. It is 6,000 megawatt. Now recently done 3 months before it was commissioned. This line was commissioned and it is active. And it is not only up to Pugalur, it is Tamil Nadu. It is from there it is going to Kerala, Karnataka also through AC link. So DC link, it is Raigarh to Pugalur, direct DC link. It is coming to southern region. Eastern region to southern region. Okay. There are some acts framed in India to regulate the electricity supply system to have or without any failures in the system. So Electricity Act, it was first Electricity Act, it was established in 1887, not now. It is during British period when the government, this electricity came into public to the public in India. That time itself this was framed. This act to amend the law relating to supply and use of electrical energy in Indian electricity is Indian Electricity Act. So this is mainly to regulate the generation, supply and use of electricity. This regulation act was framed, and it was framed again. It was replaced with the 1910. You can see the last line. This 1910 Act, and after that we are with the Electricity Act 2003. Of course, up to 93 years we were following this 1910 Electricity Act. We are following the rules, norms of 1910 Act. Now we have 2003 Electricity Act to regulate the power system. So key features of Electricity Act 2003 to have the electrical grid. or disciplined electrical grid is open access to transmission distribution system. Open access means if the transmission availability, thermal transfer capacity is available, power transfer capacity is available, from anywhere to anywhere power can be transmitted. That is called open. Openly access. Openly you can access the transmission system or distribution system. You can transfer the power from anywhere to anywhere. Then delicensing to power generation. Some of the companies like hydropowers are like mini hydros are delicensed. And trading of electricity permitted. Earlier, see in Tamil Nadu there is a company. The company should get power from the TNEB only. There is no other way to purchase the power. But nowadays, of this 2003 Act, power can be purchased from the northern region or eastern region also. Power can be purchased from the eastern region, which is a cheaper power, and can be transmitted through open access system. That is a trading of electricity is permitted, and so that any company or any utility can purchase cheaper power from the any of the company in the country. So liberal provisions for captive power generation, all the companies are allowed to generate captive power so that they need not depend on the grid supply. Their rural generation and distribution freed from the licensing. Then expanded role of regulatory commission. There are some regulatory commissions. Manik sir also came from, he is from Maharashtra, regulatory commission to monitor the total grid operation system, whether it is operating properly or not. Then unbundling of transmission distribution companies. That is unbundling. Based on the unbundling only, our TNEB was divided into two companies. That actually should be divided into two to three companies. So based on some provisions, or Tamil Nadu TNEB unbundled two companies, Stanjet and Pan Transco. That is to efficient operation and separate accounting of the system. Then regulatory commission to develop electric markets. This is a system. Before STTP Act, the power generated to given to transmission system, and through DISCOM, the consumer is getting supply. Through distribution company, the consumer is getting supply. But in the after Electricity Act 2003, you can see the consumer can get power from the GENCO, generating company directly, or power can be any customer can get power from the open access to transmission system. So it is possible not only from the distribution company, any customer can purchase the power from the generating company also. So that provision is given. Why this provision? To create a competition between the companies. That is efficiency competition. So everybody will try to give lesser cost of power consumers. So this is a power players from generator, transmission utility, central transmission or sub-transmission utility, distribution utilities, and consumer. The power can be transferred from one place to other place, or power can be purchased by the consumer from any other generator also. Then coming to regulatory commission, we have two regulatory commission to maintain the. If there is any issue, then it is like a court. It is with the judicial power, Central State Authority Regulatory Commission and the State Regulatory Commission for central and state companies. Okay. Then of course we should know about this Indian Electric Grid Code. This is what controlling the total grid system, this disciplined grid system. This grid code is laid down the rules, guidelines, and standards to be followed by various persons and particulars in the system. It is mainly to plan, develop, maintain, operate the power system. So what it tells, we'll see now. So this IEGC making the rules and standards for utilities, connecting ISTS, interstate transmission system, connecting the power system consumers to plan, develop, and operate, maintain the good power system and efficient, reliable, economic power system. That is the purpose of this IEGC, Indian Electric Grid Code, which was brought to India in 2010. It tells there are some low dispatch centers operating the total power system. They aiming for economical operation and efficient operation. What is efficient operation means? If the system failed, then immediately we should be able to restore the system. That is called efficient operation. Then coming to efficient or economical operation, least cost machine to be operated most and high cost machine to be operated least. So as already discussed, the power amount paid by the consumer is same, but power generation cost is sometime more from the diesel generator, from the gas turbine generator, etc. So we should be able to generate economical power so that the generating companies will not incur loss. Coming to load dispatch center, we have National Load Dispatch Center at Delhi. This is controlling total region. Already we have discussed 5 regions: Southern region, Eastern region, Northeastern region, and Northern region, WR, Western region. The head office NLDC is at located Delhi, and the SRLDC, Southern region load dispatch center located Bangalore. Eastern region load dispatch center located Calcutta. Northeastern region load dispatch center located again New Delhi. Sorry, Northeastern Shillong, Meghalaya. Northern region load dispatch center located New Delhi. Western region load dispatch center located at Mumbai. So these are the regulatory authorities or load dispatch authorities who are responsible for maintaining the frequency and voltage in the grid system. These are the functions. Already I have given the slide, you can go through. NLDC function is operation over the regional load dispatch center. Within the regions are properly maintained the grid or not. That is what it is going to look this NLDC. And we'll see the functions of regional load dispatch center. Role affects body to ensure integrated operation of the power system in the region. So this regional load dispatch center is affects body operation of total power system in the region. It is giving direction and exercise supervision and control which is required for integrated operation to achieve maximum and economy and efficiency in the grid system. So RLTC is playing vital role economy and efficiency system. And scheduling, rescheduling of generation is done by the RLDC. System restoration done by the RLDC. So these are the main role of regional load dispatch centers. And of course, state also we have state load dispatch center which will control the within the state frequency and the voltage control. Then how it controls? This is a Southern region load dispatch center control room located in Bangalore. From there, it controls total all 5 states and the union territory. They give instruction to all the generating stations, what is the power to be generated. They give instruction to the utility, what is the power to be drawn. So generation schedule, drawal schedule prepared by the load dispatch center, because NLC they cannot generate power as they like, or NTPC they cannot generate the power as they like. They have to generate the power what is the demand, as per demand. If they generate the power more, which is more than the demand, then frequency is higher and it is waste of energy. And if they generate less power, then the frequency is low in the system, which will lead to blackout of the system. So a person controlling the total generation and drawal is called load dispatch center. He is dispatching the load. This is called his load dispatch center. So we have in India, we have SLDC and we have 5 RLDC and we have NLDC, National Load Dispatch Center 1. Under this 5 regional load dispatch center, under which we have SLDCs. Okay. This IEGC tells what is the voltage. For example, for 400 kV system, the voltage should not go less than 360 kV and should not go more than 420 kV. If it is going more than 420 kV, then insulation failure will occur in the system. It is going more than 360 kV, then we have problem in the system. So outage planning, I will explain this outage planning. It's now say there is a demand of 3 lakh and 2 lakh megawatt in the Indian grid system. Say NLC, they want to take generator maintenance in the September month, and the NTPC Vallur, they want to take the generator in the September month. Ramagundam also September month. It should not happen. If everybody taking the maintenance of the generator for same month or same period, the grid collapse will occur. So there should be a centralized person planning the outage planning. See, all the generating stations, you can go through this one, all the generating stations by 30th November, all the generating stations, they'll give their schedule to SRP, Southern Region Power Committee. There is a committee called Power Region Power Committee. It is under Central Electricity Authority. They will submit the schedule. I am going to take this Neyveli plant in this month. Then 31st December, they will give draft outage plan program. Now let us say 31st November, Vallur plant, NTPC, NLC are giving same time. Then they will say, this power committee will say, NLC you take in the month of September, and NTPC you take in the month of October, and other plant Ramagundam you take in the month of November. So they'll divide like this, and of course now they say Ramagundam says I want to take 45 days major overhaul for the turbine, and I will get the material from the month of November only. So I cannot do in the month of September. So reschedule also can be done. So final outage program to RLDC and constituted by 30th January. So April 1 onwards, this will be implemented. That means every generating station, they cannot take their own maintenance of their plants. It will be organized by Southern Region Power Committee, Southern Region Power, as far as the Southern Region is concerned. This is how the grid discipline is maintained in the Indian grid. Otherwise, it will lead to collapse of the system. You can see here. Now every day it is planned like this. Every day, what happens? All the generating station by 6 o'clock, ISGS means Indian Interstate Generating Station. By 6 o'clock, how much they can generate? Now, for example, NLC, they can generate 2000 megawatt. They'll give to RLDC, Regional Load Dispatcher to Bangalore, I can generate 2000 megawatt for the day from today night to next day night 12 o'clock, 24 hours. By morning 6 o'clock, they will give their station-wise capacity, that is capability, that is called capability. Then 8 o'clock, they will, this SLDC will give entitlement. Tamil Nadu you take 500 megawatt, Karnataka you take 500 megawatt, Andhra you take 400 megawatt from the NLC plant. Like this, they give scheduling. That is a entitlement. That is called entitlement. Then by 3 o'clock, what will happen? This TN now, for example, Tamil Nadu, they say my one transmission line is out, so I cannot take 500 megawatt. I will take only 400 megawatt. That will be intimated to Bangalore by 3 o'clock, evening 3 o'clock. By 6 o'clock, then the SLDC, centralized location load dispatch center, will tell, okay, Tamil Nadu you take 400 megawatt, and Neyveli you generate only 4,900 megawatt instead of 4,000 megawatt. Like this only, it is all this total voltage frequency maintained. Unless otherwise all these people integrated working is not done, then it is very difficult to operate the system very effectively and efficiently. So by 11 o'clock, night 11 o'clock, they'll start the final trial schedule, final dispatch schedule. Today night 12 o'clock to next day night 12 o'clock for 24 hours. What is the scheduling is done? Now it is the schedule. Every 15 minutes they have to give the schedule. I will go show one schedule. Every 15 minutes once. You can see here. It is a Kodangulam nuclear power plant to TNEB. First one number time block 1 means it is a 15 hours. 15 minutes, that is 15 hours to 15 minutes, 15 minutes. 12 o'clock to 12 o'clock 15 minutes. Then second block means 12 o'clock 15 minutes to 12 o'clock 30 minutes. That is total 24 hours divided to 96 blocks. Total 24 hours divided to 96 blocks. Each 15 minutes, what I am going to generate, I will give to a centralized load dispatcher. What I am drawing for a day, 96 blocks I am going to give. So like this, every 15 minutes, very cleverly, very brilliantly, very efficiently it is maintained. Otherwise, it is not possible to maintain the grid system. So we see is I am getting the voltage, I am getting the frequency, that's all. But how many people working behind this? That is a very difficult. You can think over how many people are working, how they are hardly working to maintain this frequency and the voltage in the grid system. Then, if at all, now say this, I am eligible for 500 megawatt, I am drawing for 600 megawatt, then penalty will come. That is implemented by availability based tariff or called deviation settlement mechanism. So this deviation settlement mechanism will have fixed charge, variable charge, and unscheduled interchange. Okay. So what is the problem? What is the challenges in the electrical grid? Shortage of power sometimes. Then power theft happens. Power theft means not only direct theft from the transmission line, meter problem, bypassing the mechanical meters or electromechanical meters, or sometimes this numerical meter also, energy meters, poor access to electricity in the rural areas. Still, there are some villages not electrified. Huge losses in the grid system and ineffective power consumption. There are T&D transmission distribution losses occurring. Then poor reliability and power quality. So though we maintain all this quality system, frequency, voltage, still we have the problem. Shortage of power problem, reliability problem, power quality problem. So this, what is the main problem? More T&D losses. T&D transmission distribution losses are more. Then we have to invest more. That is, investment is not matched. Investment should be made like this, 2:1:1. That is, generation if you are making 2 lakhs investment, transmission you should make 1 lakh investment, distribution you should make 1 lakh investment. But it was not done earlier. Earlier generation investment was more, but transmission distribution side investment was less. That is the reason now distribution losses are more. So we have to reduce this transmission distribution losses. And not only that, when we go for like in a diesel plant or more thermal power plants, we have air pollution, we have particulate matters, we have water pollution, we have land degradation and noise pollution also we have. These are these. disconnect ஆயிச்சு வந்துருச்சு இல்லையா? ஓகே, I can go ahead. Okay. So these are the problems we are facing in the existing conventional grid. Now, what is the aim of the Government of India? Power for all. That is, sufficient power should be given, reliable power should be given, quality power should be given, and optimum power cost should be minimum, and commercial viability of power industry also. Then power for all. These are the aim of the Government of India, Ministry of Power. So how it is to be done? Now with the existing conventional grid, it is not possible to do all this. So we go for smart grid. So what is a smart grid? The present electric grid delivers electricity from generator to consumer through transmission distribution system. Now the smart grid allows new large-scale renewable energy integration. So the smart grid means renewable energy integration, first point. Wherever we have solar system can be integrated, wind system can be integrated, biomass system can be integrated, wherever they are available. Wherever they are available. It can be integrated to the grid or it can be operated independently also. That is the advantage. When we have a renewable energy system in a village, the solar system in a village, we need not take the power from the thermal station to that particular village. This will reduce the transmission distribution losses. Transmission distribution losses. Not only that, it will reduce the air pollution. It will reduce the other noise pollution. It will reduce the land pollution. So, grid integration, first they say this is a renewable energy integration. That is called smart grid. On the other part, on distribution side, the smart grid integrates new digital technology into local electricity distribution networks. Digital technology, that is data communication between the consumer to producer. So it is possible. So this combination of these two, we say smart grid. Smart grid is renewable energy integration and new digital technology, integrating the new digital technology in the grid system. That is called smart grid. So smart grid, in order to efficient deliver sustainable, economical and secure electricity supply. That is the aim of the or purpose of the smart grid is to deliver sustainable, economical, secure supply. And it should have real-time monitoring also. You can see the bottom figure which is available. It is analogy with biological, physical network, communication and information technology. Our physical network, it is a megawatt power which is available in the existing transmission line. Then communication, it is like nerves in the system, and information technology, it is the brain. Now with the physical network system, we have added communication and information technology, and that means with the muscles we have included nerve and brain system to operate the muscles very effectively. That is called smart grid system. So smart grid renewable integration and it is a data communication. You can see here. Our smart grid, it is going to be like this. The power plant, we have natural wind power, solar power, and power will be transmitted. Consumer side also will have the power sources, solar power, wind source, etc. So power to be transmitted long distance can be reduced. So it will reduce the transmission distribution losses. So these are the functions. This is consumer participation. That means consumer. Now you can see the power generated by consumer will be given to the utility also, in the grid also. The power can be pumped to the grid. So consumer become producer. Consumer becomes the producer. So real-time pricing is possible. Then distributed generation. That is incorporated renewable energy source into the grid. Then efficiency of the system. The power quality can be maintained. Then anticipation of disturbance by having the data analysis with the communication system. So today's system is with a more thermal power plants, nuclear power plants, hydro power plant, etc. But tomorrow's choice, it is going to be with hydrogen storage system, then solar system, wind system. Not only that, it is a power charging system also. That is, whatever the power vehicles, electric vehicles will charge the power to the grid. It will take the power from the grid during charging, during off time, it will charge the power to the consumer grid also. So the small wind farms. So we have come up with microgrid now. Microgrid, a small power plant, small windmills, small solar mills, so small hydrogen storage mills, small other magnetic system storages can be integrated with the grid or independently can be operated. So this is a system of smart grid. You can see smart grid not only delivers the power, it is having communication also. It is having communication. So now for this operation of the smart grid, now Government of India has made working groups like advanced transmission distribution group. There are 10 groups are made. It's one by one group. So this here, the advanced transmission distribution group, the consumer becomes the prosumer. The consumer delivers the power to the grid. So that way the consumer, two advantages. The utility need not take the power to long distance to deliver to the consumer. Transmission distribution losses can be reduced. Our main aim of the smart grid or any grid system is making the system efficiency, making the loss reduction. So the consumer himself can generate the power and to the deliver to the grid. So the power generation by the conventional energy system can be reduced. Then using facial measurement unit for better efficient system, etc. Then FACT and HVDC devices, FACT flexible AC transmission and HVDC devices can be used for the transmission system. And energy efficiency lighting system. Nowadays we go for LED system. That is also one of the smart grid system. That is called Bharat Lamp Yojana system in India. Installation of LED lamps so that the energy consumption can be reduced in the grid system. Then B also aiming for the reduction of demand side management. It is coming up with the 5-star, 3-star, 4-star rated equipment, and it is encouraging to purchase the high-star efficiency, high-star equipment so that consumption can be reduced in the system. When consumption is reduced, the loss T&D losses can be reduced. Then coming to smart cities with the LEDs, RGS mapping, SCADA system in the distribution system, and a distribution management system, outage management system, etc. included in the smart cities to making the system very effective. Nowadays, distribution management system coming with mobile workforce management also. Whatever this now we are able to make this payment online. This is also one of the APRBT system earlier, which was included in the smart grid system now. Then metering communication system. Now we are going to have automatic meter system. This already existing, and any assessor will not nowadays. It is there is a case filed in the court also. The TNB is asking more money than the consumed. So this walkaway system, mobile van will be going through houses and it will get signal from the meters, and it will take the record readings. So walkaway system also possible near future, and we will have bidirectional meters. Bidirectional meters for the prosumers, and we have prepaid meters to the consumers. Now it is coming up in India, in the Tamil Nadu. It is already in India. It is available in Tamil Nadu. It is coming up already. They have order for so many prepaid meters. Pay money first, then use the energy. Earlier we use the energy and pay money later. Sometimes we are not paying money. That is a problem. Now it is a problem will be resolved to the government, to the supplier. They will get money first for the energy utilized. Then load control. Load control is for making the peak hour generation. Peak hour, reduce the peak hour generation. Like home energy management system. Now it is we are going to have like this system. All the home will be controlled with the smart grid, or with the mobile phones, or with automatic controllers. So the smart grid going to be with more number of Internet of Things and more number of sensor, more number of controllers. You can see washing machine can be controlled, electric system can be controlled, AC can be controlled, or mobile also with mobile system, and the climate control, sunlight control, home control. With using the climate, the light will be dim, so power consumption can be reduced. Sunlight, if the sunlight is more, automatically power will be light, number of light will be switched off. So this is one of the smart grid system under coming under working group 5, load control and consumption. Then there will be policies will be made under working group 6 by CRC, Central Regulatory Authority, and the last line you can see Forum of Regulators, and digital architecture as recommended by interoperability. That means any device can be operated with any operating system. Then pilot business models also, it is under pipeline. Like now we can see the first line proposal distribution franchises, public-private partnership. That is issue going on in all the electric boards or distribution companies. Distribution will be privatized. The private people will come into this one. That is a recommendation given by the committee under the smart grid forum. That is pilot and business models. That is distribution franchises. So for distribution will be given to the some franchises, some private company. Then renewable energy and microgrids. That is what we have discussed. With the grid will be with the microgrid, small renewable energy storage system, small generators. All the residents will have its own generation things. And coming to cyber security. So when we go up with more number of technology, more number of data, more number of communication, there is a vulnerability of the smart grid in the form of cyber attack. This is a major role now, or major discussion on the short-term course we are going to have. So cyber security, it is a cyber computer security, protection of individual system, then communication security, protecting organization, communication media technology and content, network security, protection of network components and connection and content, the information technology, whatever information flowing through sky, whatever the flowing through sky, it is not in our control sometimes. So sometimes it can be hacked. The data flowing in the sky can be hacked by any person. So this is a problem now. The cyber security became a very big problem in smart grid system. So what is the conclusion I'm giving is smart grid, yes, smart grid is going to be our system in future. We will not have more number of, now also you can see, now if you see the last 2 years before, the thermal share was around 70%, now it is reduced to 65% in all over India status. Renewable energy share was it is less, but now it has improved a lot, it is increased. So that is what we are going to have our system. When we have smart grid system, definitely we are going to have communication system, data flowing, data floating. This will have hacking problem, cyber security problem also. In the forthcoming sessions, of course, we will have this discussion on cyber security and how to overcome this cyber security. So with this, I conclude smart grid, conventional grid operation, and what is the purpose of smart grid, and what is the purpose of cyber security. Anything you can discuss now. Gayatri, we have 5 minutes time.
Participants, if you have any doubts, any queries, you can post it in the chat box, or you can unmute yourself and you can talk.
Just one information, whatever I have discussed is what is happening in the real time. It is not from the any textbook manual. It is only what is happening in and around us. What we see is what is the frequency is not coming. This is a low voltage profile we are getting in the house or commercial building. But how so many people are working for this to control the voltage and frequency. That is what I wanted to give in the conventional system. I have told what is the problem in the conventional system and how to overcome the conventional system. That is what we have discussed for this for 1 hour 25 minutes. Now you can post your questions, please.
Sir, actually, I have a doubt, sir. As the renewable energies are upcoming now, do we have any provision for compressed array storage systems in the micro level?
That is again, it is not yet come, but it may come in future. There are some energy storage devices we are coming up, magnetic energy storage devices, compressed air system, hydrogen storage devices. It is all going to come up, or it will come later, not now. It is not existing now, but it is going to come in India. It will take some time. There's some research work going on for this, and definitely it is going to come up.
Okay, sir. Okay, sir. Thank you, sir. Any other queries?
Okay, participants, if there is any other query, you can route it through organizers of this seminar at any time. I am always available. You can note down my email ID, mobile number available, and you can directly call me for any doubts or any clarifications.
Sir, on behalf
Yes.
of KCG College of Technology, a very special thanks to you, sir,
Thank you.
for your wonderful and informative talk. From your session, we can understand clearly about that electric grid and its requirement, northern grid failure, IEGC and load dispatch centers, and some working groups regarding smart grid and cyber security challenges for modern power system. Thank you, sir. I hope all the participants take away the technical insights shared today. Thank you for all the participants. I request all the participants to fill the feedback form and accept the response till 2 p.m. only. Thank you, Muthukumar sir. Thank you, sir.
Thank you. Thank you. I give my special thanks to Ms. Gayatri.
Yes, sir.
Yes, please.
It's a good foundation for the 2 lectures this morning. It's a good foundation for the 1 week session which we are going to have.
Yes.
I mean, the whole scenario of the electric grid and the requirement and how to deal it and what are the new developments coming up, how to overcome the whatever cyber threats and all that will be discussed more in detail. But today's lectures are a very good foundation for this seminar, for this training program. Really, thank you very much, sir. I really thank you for the very wonderful details you gave. As you rightly said, they are all not available in the textbooks. These are all practical data and practical experiences. It's a treasure. People cannot find it anywhere.
Yes, right.
It's a very good information, and thank you very much, sir.
Thank you, sir. Actually, I should thank you, sir, because when we had discussed earlier, when I proposed, you also proposed us, we'll have some basics on this grid system.
Yes, that is
Both we are
required.
having power system and it is what is the electrical grid system. Many people may not be knowing what is a real existing grid system and what are the problem in the electric grid system and voltage frequency control. And you
Yeah.
also immediately agreed for this. That way I thank you so much, sir, for giving more starting from basic knowledge to the participants.
Yeah, because many people don't have the real field experiences. This will give them the sort of overview of what is happening, so that then take it up with the further problems which they face.
So one participant wants to ask a question. Bhaskar sir, I think you can unmute yourself and you can ask a question.
Yes, sir.
Bhaskar sir? If you're not able to unmute yourself, you can also post it in the chat box. I'll read it for you. Sir, is there one equipment needed? That's his question.
Sorry,
Sir,
what is the question?
Is there one equipment needed?
There is one
Equipment. One equipment is needed.
I'm not getting you.
Yeah, that's what. So Bhaskar, so the question actually it's not clear. Can you make it clear, or you can unmute yourself? For which one do you need?
Now, if they are not clear now, maybe they can send it through email also.
Yeah.
Yes,
Okay,
yes.
sir. Yes, sir. That will be better. Okay, Bhaskar sir, you can just put a message to me, or you can just mail me. I'll just forward the question and I'll get you the answers.
Sure, madam. Sure.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you. Bye bye.
Thanks a lot, sir.
Thank you, sir. Thank you for your kind cooperation, sir. And definitely it is going to make a good knowledge to the participants, faculty members, and students level, sir. All the best, sir. All the best.
Thank you. Thank you,
Thank
sir.
you, sir. Thank you, sir.
Thank you, sir. Gayatri ma'am, would you like to tell anything about tomorrow's session?
Yeah, you have to just announce for tomorrow. Tomorrow only one session is there, no?
Yes, sir. Tomorrow we will join at 9:45 a.m. and the day 2 session link will be sent through email and WhatsApp group. Thank you all.